See Lindelof. We have AP Calculus AB separable differential equations. In this specific one, we're going to use general solutions. So we're asked to find the general solution of the quantity x squared plus 4 dy dx is equal to xy. And you have to kind of be thinking about this as separable. So what I'm going to do is I'm going to separate all the y's to all the y dy's to one side and the x and dx to the other side. So as I do that, I'm just going to show you a little bit of the algebra. The first thing I get is dy dx is equal to xy over x squared plus 4. You can see we still have a problem with the y there, so I'm just going to keep manipulating here. This I'm going to divide both sides by y, and finally what I'm going to get this to look like is this. I'm going to get dy over y. This is just me doing the algebra here, separating these two things. dy is equal to x over x squared plus 4 dx. Is that right? Sure it is. Dx, right? So that's just the algebra part. And now what I'm going to start to do is this. I'm going to go ahead. I'm going to take the integral of both sides. So I'm going to integrate this side and this side. And hold on one second while I sneeze. All right. So I'm going to go ahead and integrate this side. You can see that the derivative over the function is an ln, right? So we're going to get ln of absolute y. And here, I don't know if you can see this or not, but this is also an ln because the first derivative of x squared plus 4 is 2x. So what we're missing is a factor of 1/2 out front. So we have 1/2 ln of x squared plus 4 dx. I'm sorry, not dx, right? Plus c, don't we? All right, so far so good. If you remember the rules of logarithmic functions, we're allowed to take this coefficient here and roll it up here as an exponential value. So we just roll this up and make this 1/2 power, right? Remember, 1/2 power is the same as the square root. So I'm going to take square root here, square root here. Now what I'm going to do is I'm going to exponentiate this thing and look at it either way you want to look at it. I'm looking at it this way. I'm looking at it as if, not as if, but I'm looking at the fact that ln is log base e. So what I'm going to do is I'm going to raise both sides to the power of, I'm going to take this e and I'm going to exponentiate over here. So I'm going to get y is equal to this e right here is this one, and all this crap here is what gets taken up to the power, doesn't it? So x square root of x squared plus 4 plus that constant value there, right? Now, this is where people get kind of freaked out by this, and it's kind of weird, but you have to think about this. Look at this, just this idea up for a second. If I take x squared times x to the third, I get x to the 2 plus 3, don't I? So what I'm saying to you is, if I started here, I could go back to this. Well, that's what I'm doing here. I'm going to go back to here. Instead of taking e to the ln of this plus c, I'm going to take this, I'm going to break it up this way. I'm starting here. I'm moving back that way. So I'm just going to take that and say I have y is equal to e to the ln of square root of x squared plus 4, right, times e to the c power. Isn't that right? That makes sense? So I'm hoping like hell that it does make good sense, because we're really getting there now. Because if you look at this now, e to the ln is just this value here, isn't it? So now we're going to get y is equal to e to the ln of the square root of x squared plus 4. It's just x, the square root of x squared plus 4 times e to the power of c. This is where people get a little bit freaked out, because they see this and they're like, what happened? Remember how we did this up here? But what we can say about this is we know e is a number, and this c value is a constant number, so e to some power is a constant, right? So I say e to some power is a constant. Remember, we're multiplying, so this is c. So we can say that our general solution is c times square root x squared plus 4. All right, is our general solution. So hopefully this is really helpful for you. I'm going to go ahead and do the next example on the next video, which is going to be particular solutions, and we're going to kind of fill in some values where we're given an initial condition. So if you haven't already subscribed, please do, and your comments are always welcome. I appreciate everything.